Introduction to experiments. Students will be able to explain the 4 basic principles of experimental design. Previously, we've looked at surveys as a way to gather data about a population. Today we look at experiments. Okay. We're no Dr. Frankensteins making monsters in our laboratory, but experiments paired with statistical analysis are a great method for determining how well or not well something works. An experiment is different from sample surveys in that a researcher will impose a treatment on individuals in the study in order to measure some outcome based on that treatment. Let's come up with a simple research question to illustrate these ideas. Does playing video games impact academic performance in teenage students? The treatment would be playing video games. The outcome would be students' academic performance. We can also think of these two variables as the explanatory variable and the response variable. The explanatory variable is whether or not a student plays video games, while the response variable would be their academic performance, which we can measure based on their GPA. As a researcher, we hope that the explanatory variable might explain the response variable. Now, another important aspect of your experiment are the experimental units. These are the individuals that will receive the treatment. In our study, our experimental units are the students that will be participating in the study. Since they are humans, we can actually just consider them subjects. Let's work a bit more on our experimental design to see if we can discover the 4 basic principles for doing a well-planned study. Okay, so let's say that we have 90 students that will participate in our study. These 90 students, let's just draw one guy for representation. These 90 students will be asked to play video games for 1 hour every day during a marking period. So we have 1 hour of video games. Every day. Okay, so now, once we have that, what I'm going to do as a researcher is we're going to take their GPA at the beginning of the marking period and at the end, and we're going to calculate their change in GPA. Hopefully you can see all of that. Now, if you think there's something wrong with this picture, take a moment, think about it, and hopefully as you come back to the video, you'll hear what we have to say. So pause the video to think about your response. Hopefully you notice that there's nothing to compare our results to. Can I say that these 90 students showed more or less growth in their GPA compared to those students who did not play video games for that marking period? A well-designed experiment must compare 2 or more treatments. So let's alter this design a bit. So now, instead we're going to have 3 different treatments that we're going to be giving to our students. Let's mark out what these treatments are. Treatment 1 is what we saw in the first example, which is 1 hour of games daily. Treatment 2 we're going to say 1 hour of games weekly. And treatment 3 we can say 1 hour of games every other, sorry you guys can't see, every other week. Now, we're still going to take students' GPAs before the marking period and at the end of the marking period so that we can see just how their GPA changed as a result of playing video games. Now, we need to figure out which students will receive each treatment. What do you think about this? And give the students with the lowest GPA treatment 1, so lowest GPAs. Students with the second lowest GPAs will get treatment 2. And then with the highest GPAs, they will receive treatment 3. What's wrong with this picture? Take a moment, pause the video, and think about your response. As researchers, if we choose who gets what, my results will certainly lead to bias. Do you remember what bias is from a couple videos ago? Bias is when we consistently overestimate or underestimate some variable that we want to measure. So how did we prevent bias when we were designing sample surveys? Let's see if you remember. We would have to randomly select our sample. Here, we need to do essentially the same thing by randomly assigning treatments to the subjects in the experiment. This brings us to our second principle of experimental design, random assignment. We always have to use chance to assign experimental units or subjects to the treatments. Why is random assignment so important to a well-designed experiment? Random assignment would ensure that one type of student does not receive one type of treatment. Random assignment would result in 3 groups that are roughly the same in makeup. They would have roughly equal number of kids with high-low GPAs, or kids who like to study versus kids who don't like to study, or kids who get 8 hours of sleep opposed to those who don't. All 3 groups should be representative of all the students that we think are in this population. Now, the next important principle of an experiment is control. This means I want to keep all variables that might affect the response the same for all groups. For example, I might want to make sure all students go to the same school to ensure that GPAs are calculated the same and students are in similar classes. I might even want to make sure that all the students in the study are actually in the same class. Can you think of any other variables that we might want to control? Take a moment, pause the video, and write down your response. The final principle of experimental design is replication. Let's say I only had 3 students for this study instead of the 90 that we talked about. One student was randomly assigned to each treatment. Would I be able to say definitively what effect that playing video games has on student academic achievement? We have to have enough experimental units in this study to be sure that differences between responses are actually caused by the treatments and not just luck of the draw. That's the idea of replication. Let's take a quick minute to review the 4 principles. We have comparison. We want to make sure that we're comparing at least 2 treatments. Random assignments. Our experimental units or subjects must be randomly assigned to each of the treatments. Control. We want to make sure that we find other variables that might affect the response variable and try and control for that. That might be harder when we have human subjects, but we got to figure out what we can control in these experiments. And lastly, replication. We want to make sure that we have enough experimental units or subjects participate in our study so that we know that the differences in response variables are attributed to the treatment and not just to luck of the draw. This stuff is tricky and conceptual. Be sure to post questions in the comment section below to get ready for a rich discussion tomorrow in class.